Now that you know all you need to know about vectors, we're going to start doing the applications. A force of 500 pounds is required to pull a boat and trailer up a ramp inclined at 12 degrees from the horizontal. Find the combined weight of the boat and trailer. So if I draw a picture out of this, first I've got my ramp, 12 degrees. Here's my boat on a trailer. You get the idea. It's being pulled up. Now you've got some forces acting on this. First of all, you've got going straight down, you've got your gravity, your force against the ramp, so it's, staying on the ramp, and then you've got the force to pull it. So we were given that it takes 500 pounds. So this is 500 pounds to pull it up the ramp. Since this is 12 degrees, this also ends up being 12 degrees. And now I need to do some solving. I need to figure out, we made this a right angle. Yeah, that's a right angle. So I can solve for, what do we want? We want the combined weight of the boat and the trailer. So what we're looking for is this whole thing right here. Combined weight of the boat and trailer. So to find that, I can do sine of 12 degrees equals 500 over x, we'll call it. So x equals, well, to solve for a denominator, let me back up and do it in 2 steps. Multiply your x over. So x times sine 12 degrees equals 500. So now x equals 500 divided by sine of 12 degrees, which equals 2,404.867 pounds. The hardest part of doing these applications is setting up your picture, especially if it's not given to you. Usually when you're dealing with a ramp, you're going to drop down your weight with the gravity, your force against the ramp, and it makes a perpendicular with the force up the ramp. Your angle of the incline is always going to end up being right here. And we'll get better with practice. Okay, this is another common problem, an airplane flying against wind. He is traveling at a speed of 724 kilometers per hour, bearing of north 30 degrees east. So if I call this my north, if I can even write an N, there we go. Okay, 30 degrees this way, 30 degrees east. I've got my airplane. He's going 724 kilometers per hour. The wind velocity is 32 kilometers per hour from the west. So that's blowing him this way. So 32 kilometers per hour going due west. Find the resultant speed and direction of the plane. My resultant is going to be this. Remember, you always add your vectors together, head to tail. So when I draw my airplane, I tack on the wind in whatever direction onto the end of that. My resultant connects the whole line of vectors. And now I'm solving this. So what I want you to get in the habit of doing is breaking each of these into their x and y components. So we're going to break down our speed of the airplane, 724 kilometers per hour. So it has an x component and a y component. Remember, we figured that out with the hypotenuse times the cosine of theta and times the sine of theta. what is that angle going to be for us? Inside that, that's going to be 60 degrees. So when you're adding vectors together and you add them together in their component form, you're going to make an x and y table. For our red vector, my x component is going to be 724 cosine 60. My y component, 724 sine 60. Okay, for my blue vector, or my wind factor, it only has an x component, 32. It doesn't go anywhere in the y. Now when I add these together, 724 cosine 60 plus 32, I'm going to get 394. And then my 724 sine 60, I get 627.002. There is my vector, or my direction. If I want to find the speed of that, okay, so here's our new picture. We now know that we go 394 in the x direction, 627.002 in the y direction. So here's my airplane. I need to figure out the hypotenuse of that and the angle that it's at. So my hypotenuse would be the square root of my x component squared plus my y component squared. So the square root of, don't ever round to the very end, go up and grab your decimals. Not a square root because I already put the square root in there. 740.519 kilometers per hour. And my angle, I would have to solve this by using tangent. Tangent of theta equals that 627 over 394. So inverse tangent, 627 over 394, 57.855. We wouldn't want to give that as the answer because in the book it gave us from north to east, so I would subtract that from 90. So I'm going 740 kilometers per hour, north 32.145 degrees east. So here's a recap of what we did. We drew our two vectors. We figured out their x and their y components. We added them together. We drew a new one. We found our angle. We found our hypotenuse. Put that together. We didn't give this angle as an answer, rather we gave this angle as the answer to make it sure it was in the same form, north to east.